In this video, we're going to look at trigonometric functions of real numbers. For each real number t, there is a terminal point xy. These are the things we looked at in previous sections. We will use the coordinates of this terminal point to define several functions. Sine of t, we're going to define to be y. Cosine of t, we're going to define to be x. Tangent of t is going to be y over x. Cosecant of t is 1 over y. Secant of t is 1 over x. And cotangent t is x over y. Notice in the rational functions, x and y cannot equal 0. First thing to keep in mind is these are functions, so you do have to have an argument, meaning the t. That's the distance around the unit circle that we're looking at. And these values are coordinates of our unit circle. So again, x and y are the coordinates of the point. Notice again, because we're looking at a unit circle, x and y cannot be greater than 1 individually. Okay? Since these trigonometric functions are defined using the unit circle, these are sometimes called circular functions. Okay? So one of the things you're going to be asked to do is to find the value of some of the trigonometric functions. And so we're going to look at 3 of the distances that we talked about in previous sections. T equal pi over 3, pi over 4, and pi over 6. So the first thing to remember is at t equal pi over 3, recall our point, our terminal point was 1/2, 3 halves. So we're in the first quadrant, both x and y are positive. Those are the coordinates for them. Okay, so the 6 trig functions that we're going to be looking at are sine, cosine, tangent, cosecant, secant, and cotangent at pi over 3. Notice in these instances, pi over 3 is our argument for each of the functions, and we want to find the values of these. Okay, so we're going to use the x and y coordinates to find them. So sine of pi over 3 is the y coordinate of the terminal point, or square root of 3 over 2. Cosine of pi over 3 is the x value of the terminal point, so 1/2. Okay. Tangent we can think of as the y over the x. So in this case, we're going to have to do some simplification. So square root of 3 over 2 divided by 1/2 gives us a square root of 3. Cosecant is 1 over y. So we're basically taking our sine and reciprocating it. And again, because we've got a fraction inside of a fraction, we want to simplify that complex fraction, but we also need to rationalize the denominator. For secant of pi over 3, we're looking at the reciprocal of our cosine. So we're looking at 1 over the 1/2, which is going to look like, again, simplifying 2. And for cotangent of pi over 3, we can think of this a couple of different ways. We can think of it as cosecant over secant, or we can think of it as the reciprocal of our tangent. So simplifying and rationalizing the denominator, we get root 3 over 3. Okay. So let's look at the next set of functions. If we're looking at our distance being pi over 4, then our terminal point is root 2 over 2, comma root 2 over 2. So here, we're going to do the same thing, except now when we look at our trig functions, our argument is going to be pi over 4, and we're going to evaluate for each of those values. The first thing to notice here is sine of pi over 4 and cosine of pi over 4 have the exact same value, because if we look at our terminal point, the x and y coordinates have the same value. Our tangent of pi over 4, which again we can think of as the y over x, we see that we just get a value of 1. For the other 3, again we can go to the reciprocals. So the cosecant of pi over 4 is going to be 1 over the root 2 over 2, which again, if we simplify and rationalize, we find that we just get the square root of 2. Secant of pi over 4, we see that we get the exact same thing. Cotangent of pi over 4, much like our tangent of pi over 4, is also going to give us a value of 1. So again, because our x and y coordinates are the same, we get the exact same value for tangent and cotangent. And then for our last value, let's look at pi over 6. Again, there we can see that our terminal point is going to be root 3 over 2, 1/2. For sine and cosine, we get the y and x coordinates respectively. And then for tangent, again, we're going to take the y over the x, which we can see we're going to need to rationalize the denominator to get root 3 over 3. For the reciprocal, again, we're going to reciprocate the y and x respectively. So for cosecant of pi over 6, we get a value of 2. And for secant of pi over 6, we get 2 root 3 over 3. Lastly, for cotangent, again, we can think of it as the cosecant over the secant, or we can think of it as the reciprocal of tangent. So again, rewriting and simplifying using the rationalization there, we can see we get a value of root 3. One of the things to keep in mind for all of your trigonometric functions is the domains of the functions themselves. So again, if we look at sine and cosine, the values there are basically just the x and y coordinates. Okay. The domain, meaning what t values we can put in, are basically any real number that we want. If we put in any real number, we can see that the x or the y, we are always going to get a point on the unit circle. If I look at tangent and secant, the two functions that have x's in the denominators, in those cases, because the x is in the denominator, I know x cannot equal 0. And so that means when I'm looking at my t value, t cannot be pi over 2 or any multiple of pi over 2. Otherwise, I'm along the y-axis where the x's are 0. So for tangent and secant, my domain is going to be all real numbers that are not equal to pi over 2 plus n pi for any integer n. And this takes care of all of those revolutions of t that we use. For cotangent and cosecant, we're looking at something similar, but here we have to be careful where y is 0. So here we want all the values where y is not 0, which means that t cannot be along the x-axis. So we're looking at things like 0, pi, 2 pi, 3 pi, etc. So our domain for cotangent and cosecant is all real numbers not equal to n pi for any integer n. Now again, just like with our coterminal angles, we may want to find values of our trig functions in other revolutions of the unit circle. Or we might want to find negative revolutions of the unit circle and find the values of the trig functions. So there's a couple of things we need in order to find the trig value of any t value. And that is, the first one is knowing what the sign of the trigonometric function is. Here, the thing you should most remember is all students take calculus. Okay? This is kind of abbreviated from what most people would say, and that's any good college student would take calculus. The reason it's simplified down is this is a mnemonic to help remember which trig functions are positive in certain quadrants. So if we think of our quadrants 1, 2, 3, and 4, and we go in that order, all students take calculus, it tells us which of the functions should be positive, and the ones not mentioned, all others, are going to be negative. So in the first quadrant, all of the trig functions are going to be positive. In the second quadrant, sine, meaning the s from students, sine and its reciprocal will be the positive ones. So in this case, sine and cosecant. In the third quadrant, the t for take corresponds with tangent, so tangent and its reciprocal cotangent are going to be the positive ones. And lastly, in the fourth quadrant, calculus, or the c, corresponding to cosine and its reciprocal secant, are positive in the fourth quadrant. Okay. So once we figure out the quadrant, we know basically whether it's going to be positive or negative, and we know the basic angles from what we looked at just previously, so we can find what the coterminal value is going to be for each of the trig functions. Okay. So let's look at a couple of examples. Let's find the value of each trig function. Okay, so this first one we're looking at the sine of 7 pi over 6. Okay, so the first thing we want to do is figure out which quadrant it's in so we can determine whether it's going to be positive or negative. Then we want to look at the reference angle to figure out what the value is going to be. And then we can use that value to find the sine of 7 pi over 6. So in this case, 7 pi over 6 is going to be in the third quadrant. Third quadrant, tangent and cotangent are positive, which means the sine is going to be negative. Reference number of pi over 6. And as we saw in the last part of the examples, sine of pi over 6 is equal to a half. So this means that our sine of 7 pi over 6 is going to equal negative 1/2. Okay, we can do the same thing for cosine. So in this case, we're looking at cosine of 5 pi over 6. 5 pi over 6 ends up in the second quadrant. Sine and its reciprocal cosecant are going to be positive, which means that cosine is going to be negative. If we look at the reference number, we again see that it's going to be pi over 6. And from what we've looked at previously, cosine of pi over 6 we know is going to be root 3 over 2. Cosine of 5 pi over 6 is going to be negative root 3 over 2. Tangent of 2 pi over 3. Okay. So again, first we're going to figure out which quadrant it is in. So 2 pi over 3 is in the second quadrant. Again, tangent is negative there. If we look at the reference angle, our reference angle is pi over 3. And so tangent of pi over 3 is square root of 3. So now, putting this together, tangent of 2 pi over 3 is going to equal a negative square root of 3. Okay. This next one gives us a negative angle to look at. And again, things work the same way. So cosecant of negative pi over 4. Again, we're going to start by finding which quadrant the angle is in. Okay. So here we can see it's in the fourth quadrant. Cosecant is going to be negative there. Our reference angle is pi over 4. And from before, we see that cosecant of pi over 4 is square root of 2. So our cosecant of negative pi over 4 is going to be negative square root of 2. Okay. Secant of 5 pi over 4. So again, we're first going to find which quadrant it's in. We see it's in the third quadrant. Secant again is our reference. Secant of pi over 4 is again root 2. So our secant of 5 pi over 4 is a negative root 2. And then our last one that we'll look at is our cotangent of 11 pi over 3. Notice 11 pi over 3 is something that's past one full revolution of our unit circle. So it's a full revolution and a little bit more. Puts us back in the fourth quadrant. Okay. Our reference angle is again pi over 3. Our reference angle, cotangent of pi over 3, gives us a value of root 3 over 3. So our cotangent of 11 pi over 3 is going to be negative root 3 over 3. The last thing to keep in mind when we're looking at the trigonometric functions and finding their values is sometimes you're going to be given information about some of the trig functions and asked to use that to find information about the other trig functions. And so here we have a couple of identities that will make this process easier. And again, these identities can be easily proven using our definitions of the trig functions that we had at the beginning of this video. So the first and probably the most important property to remember is what we call the Pythagorean identities. And in particular, there's one that's the most important, and that is sine squared plus cosine squared is equal to 1. Now I say this is the most important because if you don't remember the other two Pythagorean identities, you can always find them from this original one. In addition, if you go back to your basic definitions of our trig functions, meaning sine of t is y and cosine of t is x. Sine t squared is y squared, cosine t squared is x squared, and this tells us basically that we're looking at the unit circle. X squared plus y squared is equal to 1. Okay. Now again, the Pythagorean identity given there can be used to formulate the other two identities. So for example, if I take the sine squared plus cosine squared equals 1 and divide everything by cosine squared t, I get the next identity, tangent squared t plus 1 is equal to secant squared t. If I take the Pythagorean identity with sines and cosines and divide out by sine, then I get the other Pythagorean identity, 1 plus cotangent squared t equals cosecant squared t. Okay. Again, these will be useful not just for finding trig values, but also for some of the things that we're going to do later on in this course. The other set of identities that are very useful are the reciprocal identities. And these are ones that help with your basic definitions. So if you only remember sine, cosine, and tangent of particular trig values, meaning t's, your distances around the unit circle, you can use those to get any of the other trig functions. If I know sine and cosine, I can get their reciprocals, cosecant and secant. If I just know sine and cosine, I can find tangent by using sine over cosine to get that. And once I have tangent, I can always find the cotangent, which is its reciprocal. Okay. And likewise, you can again use the sine and cosine to find cotangent by reciprocating cosine over sine. Okay. So for the reciprocal identities, like I said, if you know sine and cosine of a trig value, you can find any of the other 6 trig functions.